Hello guys, welcome all of you. Today we have to see Colpitt's oscillator, its construction and working. Before we start the lecture, do like, share and subscribe the channel for more and more fresh content. So see, as we know, Colpitt's oscillator is a type of LC oscillator. It shows a typical Colpitt's oscillator with a tank circuit. In the tank circuit, an inductor L is connected in parallel to the serial combination of capacitors C1 and C2. See, this is the circuit diagram of Colpitt's oscillator. It uses two capacitors placed across a common inductor L. These two capacitors C1 and C2 are placed across a common inductor L, and the center of two capacitors is tapped. See here, center of these two capacitors are tapped. The frequency of oscillation is determined by the values of C1, C2 and L. See, in this circuit, the combination of C1, C2 and L works as an feedback circuit, therefore which provides a phase shift of 180 degree. Here, in the last lecture we seen that in the phase shift oscillator, three sections of RC network, that is 3 RC sections, that is RC network, produces phase shift of 180 degree. That is, those network work as an feedback circuit. In this Colpitt's oscillator, C1, C2 and L works as an feedback circuit. C1, C2 and L as a feedback circuit. So see, the resistors R1, R2 and this RE provides DC bias to the transistor. The capacitor CO or the C4, here the capacitor C4, called coupling capacitor, allow to pass AC current and block the DC current reaching to the tank circuit. This feedback circuit known as tank circuit. This circuit is known as tank circuit. So C4 capacitor allows AC current and blocks the DC current reaching to the tank circuit. And the capacitor CC, this one, the capacitor CC is called blocking capacitor, which further blocks the DC current reaching to the base of transistor. This is the transistor. The radio frequency coil, that is RF coil, this is connected between the collector and VCC supply, which acts as a load for collector and permits an easy flow of DC current and blocks the AC currents. So see, the construction one second. See here, circuit operation of the tank circuit. This is the inductor. These two C1 and C2 capacitors. This is grounded. So see the circuit operation. When the circuit is turned on, the capacitors C1 and C2 are charged. These are charged. The capacitors discharge through this inductor L, which set up oscillations of frequency F. The output voltage of the amplifier appears across C1. This is our transistor amplifier, which gives the output here, and this output appears here. That means in this Vout is appear across C1 capacitor, and feedback voltage is developed across C2. Therefore, here feedback voltage is appears across the C2. The voltage across C2, that means this, the voltage across C2 is 180 degree out of phase with the voltage developed across C1. The voltage feedback to the transistor provides positive feedback. A phase shift of 180 degree is produced by the transistor. So see here, C2 is 180 degree out of phase with the C1. This means that it produces wave of 180 degree phase shift. Correct. Therefore, this tank circuit produces phase shift of 180 degree, and this feedback to the transistor amplifier. And as we know that this transistor amplifier produces a phase shift of 180 degree. Therefore, the total phase shift of the loop is 360 degree. That means the Barkhausen criteria condition which is achieved. That means positive feedback is achieved. C. Therefore, this circuit is act as an oscillator. So this is construction and working notes for your reference of Colpitt's oscillator. This is also C. Frequency of Colpitt's oscillator. At this state, the circuit can effectively act as an oscillator, producing sustained oscillations, and the feedback ratio is C1 upon C2. Then C. The frequency of such a Colpitt's oscillator depends on the components used in tank circuit. Therefore, see the frequency formula. F is equals to one upon 2 pi into under root the components used in tank circuit, that is inductor L, value of inductor L, and the CT. Here CT means tapped capacitor. tapped capacitors. That is, C1 and C2 capacitors are tapped. That is, both are connected. Therefore, value of CT is equals to C1 into C2 upon C1 plus C2. Therefore, this formula of frequency is important for problem solving on Colpitt's oscillator. Then see advantages. It is used as a commercial signal generator up to 1 MHz. It is used as a local oscillator in radio and TV receivers. Frequency of oscillation can be easily varied, and the disadvantages are it cannot produce low frequencies. So these are the working, construction and advantages, disadvantages of Colpitt's oscillator. Thank you.